very going, I'll be going over the PowerQuery function that I wrote. And basically, what it does is it checks color blindness based on uh, red weakness, green weakness, blue weakness across 10 different levels of severity. I found a paper that was published online that kind of gave you a matrix that you can calculate, but I'll get to that in a minute. Uh, so it's a little rough right now, but basically you pass in the hex code. Let me blow this up a little bit. So hex, I can use very simple examples, but if you have a hex code, it really follows RGB. So the first two digits are red, next two digits are green, next two digits are blue after the hashtag. So a pure red would be FF, which is FF is like maxing out that that color, and then 0 is the other end of the spectrum, so that's pure red. Hashtag FF or pound FF, and then the rest zeros, that's a pure red. And as you could probably guess, this is a pure green because we're the two digits were to the green spot, maxing it out with Fs. And do 4 zeros, 2 Fs, that's maxing out. So very simple examples that I'm going to use. But to use the function, you just pass in the hex code, whatever it may be. I'm going to just to demo the function, I'm going to put in a pure red. So if I do that, I invoke, this is what you get. So you get the severity. I'm not even going to pronounce these things. But first column, that's red, weakness, green weakness, blue weakness. That's all that is. You got your severity. So it starts from 0 all the way down to 100% severity. And each level of color gives you, based on that severity, it mimics what somebody with that level of severity, with that weakness, what they would see, give or take. As you can see, it's pretty fast, even though, as I said before, the code is a little long and a little rough, and I had to hard code some things, but it's pretty performant. As you know, it works pretty well. I mean, it took like a split second for it to kind of build this out. So I was pretty happy with that. Now, backing up, let's go to the paper. So, and I'll put this in the comments, but essentially found this online. I actually found this, it was linked in a Stack Overflow. It's a paper from these researchers. It's a physiologically based model for simulation of color vision deficiency, published in 2009. And a lot of good detail here, a lot of symbology and whatever else, however you may call it. But the tutorial here was really good, and they actually gave you these matrices that you could use to calculate the simulated severities. And that's basically what I used. So I hard coded all these matrices into basically like a nested table, and then use that to calculate everything out. So if you pass in a hex code, I converted it to RGB. So, for example, a red would be 255.00. I took that 255.00 and then applied it to, when it was converted, all the matrices here, and that's what gave you the final output after converting it back to hex. So there's a lot of converting to RGB, taking numbers, running it through the matrices, doing all the multiplications out, converting it back into a hex, and then putting that as the final output. So yeah, a little complex to put together, at least for me. But I think it came out well. I tried it against Cobless, and the colors looked pretty similar when I looked at it back and forth between the two. So I go back to Power BI. Hold on a sec. So this is what the red table looks like, and as you can see, as the severity goes up on red weakness, it's pretty dark, and this kind of turns a little dark and yellowish on green deficiency or green weakness, and then blue, it seems to almost get brighter. Greens, red weakness starts to get a little bit yellow. Green, green weakness starts to turn yellow but dark, and then this starts to turn blue greenish, almost like that down there. It's almost Power BI green right there. Anyway, then blues. This starts to turn purple in green weakness, and then towards over here, that's getting very, very dark. As you can kind of see, like, it starts to get darker in these areas. Like, go to red. Like, red got really dark because of the red weakness. And the same thing happened with blue. And green, it kind of did something different, but again, when I checked it with Colos, it looked about the same. So, what's the use case for this 508 compliance? So, I work for the government. We have to comply with something called Section 508 compliance, and that's basically making sure that folks that might have visual impairments or other impairments are considered when we publish any sort of dashboards or anything like that, and it's just making sure that stuff like this, like, people can see what we're trying to say, and everything else that goes along with that. So one of the major things is color blindness. So I've been looking for ways to create faster ways of considering stuff like this. So I'm going to be posting the code into a GitHub gist. If you have any feedback, let me know. I'll still be working on it. Again, it's a little rough, but I've gotten pretty far, and I figured this is a good point to share it out. So if you have anything you want to share, let me know. Thanks.